A single covalent bond is formed between two atoms by sharing one electron each. So there is only one pair of electrons shared between the atoms. I'll tell you a few examples. With few examples you will learn. So hydrogen molecule. Lewis symbol of this. Hydrogen has only one electron in the outermost shell. So I'm going to write the symbol like this. Hydrogen. So one more hydrogen atom. So both. Hydrogen can attain a stable state by reaching the nearest noble gas, helium. So each hydrogen atom is going to share their one electron for this hydrogen atom. That hydrogen atom is going to share this one electron, and both will have a bond like this. So each will have two electrons, each will have a share of two electrons. So only one pair of electrons are shared, that is sharing electrons are only one pair. Each electron, one electron for each element. So okay, now we'll see about the chlorine molecule structure. Chlorine has atomic number 17. So 2, 10, 7 is the electronic configuration. So for representing the atom in Lewis symbol, we are going to consider the valence electrons, 7 electrons. So chlorine, so I'm going to write the 7 electrons, 1, 2, 3, 4, 5, 6, 7. This is one chlorine atom. Another chlorine atom, I'm going to take this 1, 2, 3, 4, 5, 6, 7. So both will share one electron each, so that each chlorine atom will have 8 electrons. So it will reach, it will have the electronic configuration. Each will have the electronic configuration of nearest noble gas of argon. So chlorine atom 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. The seventh one I'm going to write here. So for this one, chlorine atom 1, 2, 3, 4, 5, 6, 7, 8, 1 like this. So each one is going to share one electron. Okay, now these two electrons are by one electron by this chlorine atom and another electron by this chlorine atom. Each one is contributing one electron. So a single pair of electron is shared between them. That's why it is represented by a single line or a single bond. We say the small single line as single bond. Single bond represents a single pair of electrons shared between the atoms. So ammonia molecule NH3. So nitrogen electronic configuration is 7, atomic number is 7, electronic configuration is 2, 5. Lewis symbol I'm going to write for this N. So 1, 2, 3, 4, 5. So 5 electrons in nitrogen atom, the outermost shell in Lewis symbol. Then hydrogen, how many hydrogens are required? 3 hydrogens. So hydrogen I'm going to put a cross like this. Lewis symbol, you can use a cross or a dot to represent the valence electrons. So 3 hydrogen atoms. So I'm going to write like this N, 2 dots like that only. Then 1 hydrogen atom here, another hydrogen atom here, and this one, another hydrogen atom here. So electrons completed. So hydrogen has 2 electrons each. Then if we go for nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen has also attained the octet state by sharing 3 electrons each. So we have 3 single bonds and 1 pair of electrons are not shared. So like this we are going to have 3 single bonds between hydrogen and nitrogen, and 2 electrons are not participated in the bonding. So these 2 electrons which did not participate in the bonding are called lone pair, L-O-N-E, lone pair, which did not take place in bond participation. This is for nitrogen. So these are called lone pair. Okay, formation of methane molecule. So carbon has 4 valence electrons. So I'm going to write 4 dots like this, the Lewis symbol for carbon, and 4 hydrogen atoms. 4 for hydrogen I'm going to put a cross to represent the valence electron. So you are going to share 4 hydrogen atoms with 4 valencies of carbon. So 4 electrons. Hydrogen. Here 1 carbon electron and a hydrogen electron. Here 1 carbon electron and the hydrogen electron. carbon electron, hydrogen electron. So hydrogen has a completely filled valency 2 2 2 2. So 2 electrons are filled. Now for carbon, so 8 electrons are filled. So carbon has now 4 single bonds which are made with hydrogen atoms. Those single bonds are represented with single lines. This is about the single bond formation between different atoms to form molecules. Covalent bonding, covalent, single covalent bond. Formation of double bond. So oxygen molecule, oxygen atomic number is 8, electronic configuration is 2, 6. So oxygen molecule, I am going to draw the Lewis symbol for this. 1 2 3 4 5 6 for oxygen atom. So one more oxygen atom. 1 2 3 4 5 6. So 2 atoms. So each has 6 electrons and this one has 6 electrons. Each require 2 electrons. So 2 electrons of one atom will be shared with the 2 electrons of another atom. So if each atom shares 2 electrons, then the bond formed is called double bond. So contribution of 2 electrons for each atom, we call it as a double bond. Or we'll have 2 pairs of shared electrons between the atoms represents a double bond. So oxygen, one atom, 1 2 3 4. This 5 and 6 here. Another atom, 1 2 3 4 5 6. So this oxygen atom has 1 2 3 4 5 6 7 8 electrons, and this one also has 1 2 3 4 5 6 7 8. So when we are representing the molecule, we are going to write like this. The double bond is represented with 2 short lines. O2 molecule, this represents 2 shared pairs of electrons, 2 pairs of electrons being shared between these. So one shared pair, second shared pair. So 2 electrons will be contributed by each atom which participate in a double bond. CO2 molecule. So CO2, one carbon atom, 1 2 3 4, and 2 oxygen atoms. So oxygen, what I'm going to do is I'm going to change the symbol like this, CO2. So 2 oxygen atom. So that structure of the molecule which you are going to get is C will share 2 electrons of it with 2 electrons of oxygen. So remaining electrons of oxygen are 6. Then this 8 electrons are filled now. 1 2 3 4 5 6 7 8. The another 2 electrons of carbon is shared with another oxygen atom. So 1 2 3 4 5 6. Oxygen here has 1 2 3 4 5 8 electrons in the outermost shell. Now this carbon will have 2 electrons shared between 2 oxygen atoms. So we have carbon having double bond with each oxygen atom and CO2 molecule. It is something like C double bond O, C double bond O, and C double bond O. So 2 double bonds between carbon and 2 oxygen atoms. So if we go for triple bond, formation of nitrogen molecule, now 3 electrons of each atom are shared with 3 electrons of another atom. So we will have 3 shared pair of electrons. So nitrogen molecule, nitrogen atomic number is 7, electronic configuration 2, 5. So I am going to represent these 5 electrons in Lewis symbol 1 2 3 4 5 plus another nitrogen atom 1 2 3 like this, 1 2 3 1 2 3 4 5. So each nitrogen atom is going to share these 2 electrons. I am going to put like this. These are lone pair, they don't participate in bonding. 1 2 3. So 5 electrons of one nitrogen atom and another 3 electrons of another nitrogen atom. So one more lone pair which do not participate. So this is how the molecule formed with first pair, second pair and third pair. So 3 pairs of electrons are shared between the atoms which are represented by 3 single lines, 3 lines, which we call them as a triple bond. 3 pairs of electrons are shared between the 2 atoms. This molecule C2H2, you will learn more about this. So it is called ethane. So this is formed by a triple bond between carbon atoms. So how it is formed? Carbon valency is 4, 1, 2, 3, 4 plus 2 hydrogen atoms. So hydrogen atom, each valence electron is 1. Each carbon atom, I'm going to draw like this. So each will share 1 electron with 1 hydrogen atom. So this will share 1 electron with 1 hydrogen atom. So hydrogen is completely filled. Now how many electrons are left for carbon? 3 electrons are left. So 3 electrons of this carbon atom are shared with 3 electrons of another carbon atom. So they form a triple bond like this. So that this carbon atom will have 8 electrons, and this will also have the 8 electrons. That is, valencies are filled completely now. So you will have the structure of this in bond representation as C triple H single bond, C triple bond C H. So this will be the structure of ethane molecule. This is also called as dot representation. So dot representation or molecular structure. So representation of molecule with the dots. So this is about the covalent bonding, single, double and triple. We will learn about differences between ionic bond and covalent bond. So ionic bond you have learned in the metals and non-metal lesson. So it is formed by the transfer of electrons. So positive ions and negative ions are formed generally between metals and non-metals. So I'll write the first point as it is formed by transfer of electrons. Small example I'll give. So sodium, I'll draw this one with a Lewis symbol. Sodium atom, and sodium chloride is an ionic compound. So sodium 1 chlorine has only 7 electrons in the outermost shell. So this is 7 electrons, 1, 2, 3, 4, 5, 6, 7 electrons. NaCl is formed. This electron is there in the sodium. Sodium has 11 electrons, so it loses 1 electron. So sodium can lose an electron and form Na plus ion. So this lost electron will be gained by chlorine, and chlorine valence is satisfied. So since it got an electron, it forms a negative ion, Cl minus ion, Na plus and Cl minus. So both will combine with strong electrostatic force of attraction, NaCl. So this is how an ionic bond is formed between two positive and negative ions. Now how is a covalent bond formed? It is formed only by sharing of electrons. So that two valence electrons, sharing of valence electrons between the atoms. So here we will take a small example of formation of hydrogen molecule H, and another hydrogen atom with 1 electron in the outermost shell forms H2 molecule by sharing each 1 electron. So a single bond between these two. So a bond covalent is formed by sharing of electron, and ionic bond is formed by transfer of electrons. Generally they have very high melting and boiling points. So they have high melting point and boiling points. Why do they have high melting and boiling points? Because between the ions there is strong force of attraction. So these we don't call them as molecules, but we call them as formula units. So these formula units have very strong electrostatic forces of attraction. So large amount of heat is required to melt them. What about the boiling points and melting points of covalent compounds? Covalent compounds generally they have low melting and boiling points. What is the reason for low melting and boiling points? See here, the molecule which is formed by sharing of electrons is so stable. It's very strong. Internal forces are very strong, but the forces of attraction between the molecules is less. So as the force of attraction between the molecules is less, they can be easily changed, or they can be easily melted, or the molten one can be boiled easily by providing little amount of heat energy. So that's why their melting and boiling points are less. So ionic compounds, most of the ionic compounds exist in solid state like NaCl, KCl, parasulfate, FeSO4. Then all are generally crystalline solids. When we go with the covalent bond, it is generally between the non-metals and that exists in all the three states. So covalent compounds exist in all three states, solids, liquids and gas. But in aqueous solution, aqueous or in molten form, they are good conductors of electricity. In molten form and in aqueous solutions, ionic compounds are good conductors of electricity. Here covalent compounds, since they don't have any charged particles, they never conduct electricity, though they are in solids or liquids or gaseous form, so they are poor conductors of electricity. One more important point in this is these reactions takes place instantaneously. You have learned in your first chapter in chemistry about double displacement reactions. One regular reaction which you come across is sodium sulfate plus barium chloride. Both are colorless transparent solutions when dissolved in water. Now immediately when you mix them, they are going to result with one solid precipitate of barium sulfate, and then you will have sodium chloride solution. So this reaction takes place instantaneously. So ionic reactions takes place instantaneously, very fast. Whereas the covalent compounds, the bonding or the formation of a covalent compound is very slow. And one more thing is, it even does not proceed to completion. Example, CH4 methane gas in the presence of sunlight reacts with chlorine to form CH3Cl plus HCl, chloromethane. So this, as compared to this reaction, ionic instantaneous one, this is slow. But if you are allowing this for some more time, again this chloromethane will react with chlorine to form dichloromethane. So this type of reactions which do not occur to the completion at one, reactions are possible with the covalent type of bonding. Okay, and thank you very much.